Hi, I am Miss Oliva, and I'm going to go through material from 2.1, which is quadratic functions and applications. And let's get started. So we have already gone through transformations. So we've already done moving things left and right and reflecting them and all that stuff. Well, this unit, we're going to be focusing mostly on just the quadratics, where before we were doing it with quadratics and absolute values and rational functions. So remember, the parent graph for a quadratic function is y equals x squared. And that is just a parabola whose vertex is at 0, 0 and goes up. So what if these things were happening? Remember that this would move it to the right one, and this would move it up one, and this would flip it, reflect it over the x-axis, so it'd flip it down. So if it's asking me if the graph opens up or down, I know because of those transformations that it's going to go down. So the key is the a, because a is the number in front of all of this, and right now it's a -1. If a is less than 0, like ours was, it will open down. And if a is greater than 0, it would have opened up. Now, what is the vertex? Well, remember that it's normally 0, 0. So if we have moved to the right one and up one, wouldn't that just move our vertex over there? And then we know it would flip. But just for the vertex, it would be +1, +1. So another way to think of that is if it is in this form, only if it's in this form, we're going to see other forms in a minute that are going to take some more work. If it is in this form, the vertex will always be the opposite of this number, and then this one as is. Okay? Determining the x-intercepts, which is the same as the zeros. So make sure you know that. So if it ever asks you to find the zeros, it's asking for the x-intercepts. And so you always start by plugging in 0 for the y. And then we will just solve. So I will subtract that 1 to the other side. I will get rid of this negative next before I deal with the square. So basically I'll divide both sides by -1. And now I'm here. I cannot do anything with that x minus 1 yet because it's in the parentheses. I have to deal with the square first. So to get rid of that square, we take the square root of both sides, but be careful here because remember, when you do that, you always end up with 2 answers. So the square root of this just gives us x minus 1. The square root of 1 in this case really gives us plus and minus square root of 1, which is +1 and -1. Because the square root of 1 is 1. So now for my last step, I'm going to add 1 to both of these. So I'm going to get 2 totally different answers. So 1 plus 1 is 2, but -1 plus 1 is 0. So these are my x-intercepts. If I wanted to write them as points, it would be 2, 0, and 0, 0. Determine the y-intercept means to do the opposite. So I'm going to say f of x, or I'll just say y equals -0 minus 1 squared plus 1, which equals -1 squared plus 1. -1 squared is +1, but then I have this negative outside. So I get 0. So the x-intercept, 0, 0, is the y-intercept, which makes sense. If both are 0 there, then it's going to be an x-intercept and a y-intercept. Okay, that should be enough to sketch. If I know my vertex is at 1, 1, I have a point here and a point here, and I know I'm going down, I must have something like this. Now, determine the axis of symmetry. This is something we've maybe never talked about, or you've maybe never heard. The axis of symmetry is just the imaginary line that goes straight down the middle. that would be symmetric, right? My picture's not perfect, but supposedly this would be the exact same as that. There'd be like a reflection there. So since it's always a vertical line, it's always going to be x equals a number because that's how we write vertical lines, right? X equals some number. So in this case, it just happens to be that it would be x equals 1. So basically, this should always be the same x as the x in your vertex, since it's going straight through that point. So does this graph have a max or a min? Does it have a very highest point or a very lowest point? Well, the arrows mean it's going to go down forever. So it does not have a min, but it does have a highest point. And that point is the vertex. Domain for all parabolas that either open up or open down, since the arrows will be going forever to the left and forever to the right, even though these are going down, remember domain is the x's. So this way they're going negative, but this way my x's, even though the graph's going down, my x's are going to be getting bigger and bigger and bigger. So I am going from negative infinity to infinity with my domain. For the range, if I start at the bottom, I hit an arrow, which means it goes forever in that direction. So I'm coming from negative infinity. If I hit another arrow at the top, I'm going to infinity, but I don't. This graph stops exactly at 1. Make sure you have a bracket because there's no open circle there. Okay, so most of this was a little bit of review. I think the axis of symmetry and identifying a max or min was maybe new, but nothing else should have been too brand new. Now, what if it is not in the nice vertex form? Well, there's a couple ways to get what you want. And one way is just to change the look of the equation so it is the way we want it. And the first thing you need to know before we even try to do that is how to complete the square. Completing the square means if we had something x squared plus or minus something x, and we could put any number there we wanted, what would be the best number to put there that would complete this square? Meaning I could then factor it really nicely. It would always work out to something nice. Well, there's a little trick to get that nice number, and it's you take the b, which remember is this, the number next to the x, divide it by 2, and then square it. Which is why even when b is negative, that magic number that we're going to get is always going to be positive because we square whatever we do here. So even if b was negative and we divided by 2 and got a negative, we're still going to square it. So this will always be positive. So for a, I am taking 4, I'm dividing it by 2 to get 2, and I'm squaring it. So it just happens to be 4. Do we agree that that is something that would factor nicely? Yeah, right? X plus 2 times x plus 2, which means we could just say x plus 2 squared. It's always going to be like that. It's always going to be 2 of the same thing, so we can just say this squared. So let's try to do that without going through all the steps for the next one. So first of all, what's our magic number? Half of this, so -5 squared, 25. So how could I rewrite this so it's just x plus or minus something all squared? Well, it's always going to come from half of this, right? Because -5 and -5 would get us that 25, but 2 -5's x will get me this. So if I'm losing you, this is something you can memorize, that to get the number, you take half of this and square it, and then to put it nicely in this form, you just do x plus or minus whatever half of the b was. So one more. Half of -8 is -4, which means I can already tell you what this will be, even though I haven't even completed this square. Because this part comes from half of this. But the number that would need to be here to do that would be the -4 squared, which is 16. So right now we are doing this for no reason at all. We're just trying to learn this thing called completing the square. Then we're going to do it for a reason. Okay, so how do we use that to actually do something useful? So if they give me an equation in this form and they're asking for vertex form, they want something like this. This would be vertex form. So I don't have that, right? So I would like to change this to something that looks like this in order to have it in vertex form. So 45 is a problem because 45 does not help me to factor this nicely into two things that are the same. So I'm going to use completing the square to do this, which means I'm going to kind of put that plus 45 off to the side. I'm going to ignore it for a second because we didn't like it. And I'm going to complete the square here. So what is the number I would add to complete the square? Half of 14 is 7. 7 squared is 49. Now, that should feel weird that we had x squared plus 14x plus 45, and now we randomly have all of that plus a 49 that just came out of nowhere. Well, I want that plus 49 there because I know it will help me get to this. But I cannot do that just out of the blue unless I also do the opposite. Because if I randomly add 49, but then I also randomly subtract 49, haven't I really done nothing as far as changing how much this is worth, right? I added 0 basically, so that's fine. But this will help me change the look of this equation, and that's what I want. So this we know now will all change into x, half of this, so plus 7 squared. And then to see what's on the outside, let's see what happens when we do that minus 49 to make it fair. 55 minus 49 is minus 4. So this is our equation now in vertex form, which means if I asked you the vertex, it would be -7, -4. Because remember, we do the opposite of this and then this as it is. So if you want to try that on your own now, I would maybe pause, try it, and then see if you did the same thing I do. Or if you're not ready, you can watch me do it one more time and then try pausing it. So here I go for this one. X squared plus 10x. I'm going to decide what is the nice number to add. So over here, I'm going to kind of put that plus 16 out of the way. The magic number I want to add is half of this squared. So that's 5 squared, which is 25. But then I have to be fair and undo that since that came out of nowhere. This can be written now nicely like that. And 16 minus 25 is -9. So my vertex, if they ask me, would be -5, -9. Try one more. So if you haven't tried one by yourself, I would definitely do this. So pause and do it, and then let me do it for you. So leaving space for the number I'm going to add that will help me make this look the way I want it to look. So half of -16 is -8, but then if I square it, I get 64. But if I add 64 randomly, I need to subtract 64 randomly. So what do we get? -25 over here. But in here, it becomes x minus half of this squared. So this sign in the parentheses should always match whatever your b sign was, right? When we had a plus 10x, it became a plus 5. When we had a minus 16x, it became -8. So what is our vertex? +8, -25. What are our x-intercepts? I'm going to come down here to solve that. I'm going to set the equation equal to 0 and solve. So when we add 25 in this case, take the square root of both sides, which means we're going to have a positive and a negative 5. So I'm going to write those separately because I now need to separately add 8 to each of those. So x equals 13 and 3. So those are my x-intercepts. All right, and now my y-intercept. If I plug 0 into this function, I would get 0 minus 8, which is negative 8 squared, which is 64, minus 25, which is 39. And now for the sketch. So I went by 2's here, but I think that still isn't good enough. I'm going to run out of room. So I'm just going to kind of estimate this, but we need to be at about 3 and 13 on here. I know that we're going up because there was a positive 1 as my A, but my vertex is 8, 30, oh. Wait, that doesn't make sense. Oh, the vertex was 8, negative 25. Okay, sorry. 8, negative 25. So that is about here. And so it's the vertex that's way, way up. So that's fine. We'll just estimate it. Just making sure it makes sense. So that y-intercept's going to be way up here. But this is my x-intercepts and my vertex, which is usually good enough to graph. So what is my axis of symmetry? Well, remember, it's just the dotted line that goes through your vertex. So it's always going to be x equals, and it's going to be the same x as your vertex. So in this case, x equals 8. Is there a max or min? There's a min, and it is, again, the vertex, 8, negative 25. My domain, since my arrows are going left and right, is same old, negative infinity to infinity. But my range, I need to be a little more careful. If I'm coming from the bottom, there are no arrows here. So I am not coming from negative infinity. The very first value that is being used is that negative 25. So bracket, because it's not an open circle, negative 25, and then it goes up forever, parenthesis. Okay. We're going to do the completing the square again, but this time I just want to make sure you see what happens if there's a number out front, because we haven't had that yet. So first, that plus 17 that we don't like, we're just going to kind of move over to the side. We want to add the magic number that helps us complete this, but if there is a number in front, if there's an A that is bigger than 1, you first need to factor that out, but not with the 17. Just with these two, because these are the two things we use to complete the square, right? So negative 6 divided by 2 is negative 3, squared is 9. But here's where you really need to be careful. Then most people would want to go over here and say minus 9. No. I did not just randomly add 9 to this problem. I added a 9 inside a parenthesis with a 2 outside. So isn't that really 18? So if I randomly added 18, I also need to subtract 18. So my equation becomes 2 is still on the outside. This can nicely change into x minus 3 squared, and 17 minus 18 is negative 1. So as far as what the vertex is, that 2 does not do anything to the vertex. It will change the shape of the graph. It will make it go up a little faster, but my vertex still comes from opposite of this number, so positive 3, and then this one as it is, -1. So maybe pause and try the next one before I do. We need to pull the 2 out. Of those two only, the +7 can just hang out here for now. To complete the square, I take half of -4 and I square it. So -2 squared is 4. But what I really did was I randomly added a 4 times a 2. So I added 8. So I need to subtract 8. So x minus 2 all squared is what this nicely turns into. 7 minus 8 is -1. This time my vertex is +2, -1. Now, what if they also wanted me to find the x-intercepts? We need to be careful because that 2 might make it so they're not that nice. So what would I do to find my x-intercepts? I set the equation equal to 0 like always. I would add 1. I would divide by 2. Now square root both sides. So plus and minus. The square root of 1 is 1, so I can do that, but the square root of 2 is not nice, so I'm just going to leave it like that. And then my last step would be to add 2 to both of those. So it's not always going to be super nice, pretty answers. Okay. New form. So another way to find the vertex, if that's all you're trying to find, instead of doing this whole completing the square, which takes a couple steps to change the look of it, and then get the vertex, you can get the vertex almost right away by using this new formula. So the vertex formula is this. To find the x of your vertex, you do opposite of b over 2a, which should look familiar because you see it's this part of the quadratic formula. And then this looks super fancy, but all it means is since you have the x, now go plug that x in to find the y. That's all this means. So to find the x of our vertex, we do the opposite of b over 2 times a. So that would make that a positive 48 over 8, which is 6. So we are halfway done. So the vertex is 6 something. Well, if you ever have an x and you want to know the y, you can always just plug it in. So to find the y, we're going to plug 6 in and see what we get. So make sure you square the 6 first. So 6 squared is 36, times 4 is 144, 48 times 6 is 288. So if I do all that in my calculator, I get -29. All right, so again, if you want to try one, go ahead. Make sure you see there's a negative here. So A is -1, B is -2, and C is -3. So you should get -1 for your x. And then go plug that in carefully. Again, make sure you square first before you multiply, even if it's only a negative. So this would be +1 times negative. This is a negative and a negative, so it becomes +2 minus 5. So this is 1 minus 5, which is negative. So that is how you use the vertex formula to find the vertex. But if the question said put this in vertex form, you would really need to do the completing the square. All right, word problem. The monthly profit for a small company that makes long sleeve t-shirts depends on the price of the shirt. If the price is too high, sales will drop. If the price is too low, the revenue brought in may not cover the cost to produce the shirts. After months of data collection, the sales team determines that the monthly profit is approximated by this equation, where P is the price per shirt and F of P is the profit. So, A, find the price that maximizes the profit. So they want to know the P, okay? So what is the P? What is the magic price for these shirts that would give us the most money possible? Well, if you're dealing with a quadratic, it either looks like this or it looks like this, right? And we have a negative out front, so we know it looks like this. So if we want the maximum profit, wouldn't it be here? Because that's the highest point in the graph. So in other words, it would come from the vertex. So they're asking us, what is the P, which is like our X here, that maximizes the profit? So here they're asking us for X. Then they're going to ask us, well, what is the maximum profit then? So that's basically asking us for the Y. So all it is asking us is for the X and the Y of the vertex. And we just did that, right? We have a formula that we can do, or we can use to do that. So that's all you need to do here. So the hardest part is just understanding what they're asking. Oh, they're just asking me for the X of the vertex. I can use this formula. So opposite of B over 2 times A. See what you get. 18. So apparently $18 is the best price for these shirts. It makes us the most money. Now, how much money does it make us? Negative 50. Let's plug our 18 in there. Plus this times 18 minus this. Make sure you square your 18 first before you multiply by negative 50. And then add whatever 1800 times 18 is, and then subtract the 16,000. You should get 200. Okay? So C, find the prices that would allow the company to break even. Well, break even means you don't gain any money, but you don't lose any money. So it means your profit equals 0. So in this problem, profit is like the Y, right? X is the price of the shirts, Y is the profit. So they're basically asking you to find out when the Y would be 0. So they're asking us to solve this. So these are big numbers, but the good news is we can factor something out right away. So I'm going to take out negative 50, which means I need to divide that out from everything. So we get negative 36, and we're going to get a positive 320. So those are still pretty big numbers. So you can kind of guess and check at this point. But basically, we want two numbers that multiply to 320 that could add up to 36. But we know they would both have to be negative in order to have a positive here and a negative here. So if I split up 320 into 32 and 10, I would try those first, but that's not going to work, right? So instead of picking a lot of other numbers that multiply to 320, because I don't really know a ton, I'm going to first break these down more to see what numbers I'm even working with. So a 32 can be split into an 8 and a 4. A 10 can be split into a 5 and a 2. And then we could go even further. So now I just have more options because I know I can do any combination of these. So for instance, 4 times 2 is 8. So let me see what I get when I divide 320 by 8. I get 40. So I'm going to come over here now. So we already tried 32 and 10. Now I'm trying 8 and 40. That still won't get us to 36, right? So how about 320 divided by 20? That would be 20 and 16. So I might not have known to try 20 unless I saw what my options were. So here's 10, which I already tried, but what's 10 times 2? 20. So that's how breaking it all the way down can help you to figure out what numbers to even pick from when they're bigger. Obviously, you probably don't need to do this when you're doing something like 30, right? You know all the factors of 30, 3 and 10, 6 and 5, 2 and 15, but I didn't know all the factors of 320 offhand. So that's why I did this. So now I know that minus 20 and minus 16 would give me that positive here, but would add up to negative 36. So what are my options? Positive 20 and 16. These are the prices that would help me break even. Okay, last thing in this unit is the discriminant. So again, remember the quadratic formula is opposite of b plus or minus square root b squared minus 4ac all over 2a. And we talked earlier that this part of the equation apparently is helpful for us to find our vertex. Well, the discriminant is b squared minus 4ac. So do you see that that's just this part? Just make sure you understand the square root is not part of the discriminant. The discriminant is just the number that ends up inside here. And what's nice about that is it tells you something about your x-intercepts. It tells you how many x-intercepts you're going to have. So if you just do the discriminant instead of having to do this whole entire thing, if you get 0 as your answer, that means there is 1 x-intercept. If you get a positive number, which means a number greater than 0, there are 2 x-intercepts. And if you get a negative, there are none, because if there's a negative in the square root, we end up with i's. So i's are not real numbers, so they're not going to show up on a graph as an x-intercept. So the question would just say, find the discriminant, and then maybe tell what it means as far as how many x-intercepts. So here's my b. So b squared minus 4ac, I get 16 plus whatever 16 times 3 is, 48. So I get 64. Since that is a positive number, and that's all I need to know, it's positive, it means what this means, right? So it means I have 2 x-intercepts in my problem. So that would look something like this, right? It means we're hitting twice. If there was only 1 x-intercept, it would look something like this. It would just hit, but not go all the way through, and it would just bounce back up. And then if there was none, it'd be something maybe like this, where it's so low or it's so high that we never hit the x-intercept. So this is 2, 1, 0, just what they would look like. Okay, so that's all it would ask you right here. What's the discriminant? 64. What does it mean? There are 2 x-intercepts. So let's do another one. Opposite. B squared, not the opposite of b, sorry. B squared minus 4ac. So that's 9 minus 120. And so that is a negative number, negative 111. So again, we don't really care much about it. We care if it's positive, negative, or 0. So the second we realize that this is going to be a negative number, what does that mean? it means there will be no x-intercepts. So the graph's going to do something like this, either be way below the line and it never hits the line, or maybe way above the line and never hit the line. Okay, that is it for 2.1. Let me know if you have any more questions as you're working through the homework.